Hello and welcome to Job Seekers Paradise. We are thrilled to bring you an exciting and comprehensive series that will turbocharge your AWS interview preparation. If you are aiming to excel in your AWS interviews, you are in the right place. In this series, we are going to dive deep into over 250 AWS interview questions and provide you with clear, concise, and insightful answers. Whether you are a beginner looking to build a strong foundation or a seasoned pro aiming to fine-tune your skills, we've got you covered. Before we jump into the questions, here's a quick request. If you find value in our content, if you learned something new, or if you're excited about ACING your AWS interviews, remember to hit that like button. It really helps us know what you enjoy and encourages us to create even more valuable content for you. Don't forget to share this series with your friends and colleagues who might also be on their AWS interview journey. Let's help each other succeed. And of course, if you haven't already, please subscribe to our channel and hit the notification bell so you won't miss any of the upcoming videos in this series. We are dedicated to helping you reach your career goals, and subscribing ensures you're always in the loop with our latest insights and tutorials. So, are you ready to boost your AWS interview confidence? Let's get started. Remember, we're here for you every step of the way. Thanks for tuning in, and let's embark on this learning journey together. 43. What are the types of backups in RDS database? In Amazon RDS, Relational Database Service, there are several types of backups available to help you protect your database data and ensure data availability in case of accidental data loss, hardware failures, or other incidents. The main types of backups in RDS are automated backups, manual snapshots, snapshot copies, enhanced backups. 44. What is the difference between security groups and network access control list? Security groups and network access control lists, NACLs, are both network security features in Amazon Web Services, AWS, that help control traffic and enhance the security of resources. However, they operate at different layers of the network stack and offer distinct functionalities. Here's a comparison of security groups and NACLs. Security groups. 1. Can control the access at the instance level. 2. Can add rules for allow only. 3. Evaluates all rules before allowing the traffic. 4. Can assign an unlimited number of security groups. 5. Stateful filtering. Whereas 1. Network access control list. 2. Can control access at the subnet level. 3. Can add rules for both allow and deny. 4. Rules are processed in order number when allowing traffic. 5. Can assign up to 5 security groups. 6. Stateless filtering. 45. What are the types of load balancers in EC2? There are 4 types of load balancers. Application load balancer, network load balancer, classic load balancer, gateway load balancer. 46. What is an ELB? ELB stands for Elastic Load Balancer, and it's a service provided by Amazon Web Services, AWS, that automatically distributes incoming network traffic across multiple targets, such as Amazon EC2 instances, containers, IP addresses, and more. The purpose of an Elastic Load Balancer is to improve the availability and fault tolerance of applications by distributing traffic evenly and efficiently among the available resources. ELB handles the complexities of traffic management, health checks, and automatic failover, making it easier to build highly available and scalable applications. There are 2 main types of elastic load balancers in AWS. Application Load Balancer, ALB. Network Load Balancer, NLB. 47. What are the 2 types of access that you can provide when you are creating users? When creating users in AWS, you can provide different levels of access to resources and services using 2 primary types of access: programmatic access and AWS Management Console access. Programmatic access. Programmatic access involves providing users with access keys, access key ID and secret access key, that allow them to interact with AWS services programmatically using the AWS command line interface, CLI, SDKs, and other tools. Users with programmatic access can write scripts, automate tasks, and develop applications that interact with AWS resources. Use cases. Automating infrastructure provisioning and management. Developing custom applications that interact with AWS services. Managing resources through code and scripts. AWS Management Console Access. AWS Management Console Access provides users with a web-based interface to interact with AWS resources visually and interactively. When users log into the AWS Management Console, they can use the console's graphical user interface, GUI, to manage, monitor, and configure resources. Use cases. Managing resources through a user-friendly web interface. Monitoring and analyzing usage and performance metrics. Setting up and configuring services using wizards and forms. When you create an AWS user, you can grant them one or both types of access, depending on their roles and responsibilities. Additionally, access permissions can be further controlled and customized using AWS Identity and Access Management (IAM) policies. IAM policies define what actions users or groups of users are allowed or denied on specific AWS resources. 48. What are the benefits of auto-scaling? The following are the benefits of auto-scaling. Optimal performance. Auto-scaling automatically adjusts the number of instances based on the incoming traffic load. High availability. By maintaining the desired number of instances, even during failures or traffic spikes, auto-scaling enhances the availability of your applications. Cost savings. Auto-scaling helps optimize costs by automatically scaling up or down based on actual demand. Resource efficiency. Auto-scaling ensures that you have just the right amount of resources to handle the workload, avoiding resource wastage and inefficient use of capacity. Flexible configuration. Auto-scaling allows you to define scaling policies and rules based on various metrics, such as CPU utilization, network traffic, or custom metrics. T6. Ease of management. Instead of manually provisioning and provisioning instances, auto-scaling handles the process automatically. 70. Predictable performance. By maintaining a consistent number of instances, auto-scaling helps maintain stable performance even during traffic fluctuations, ensuring a consistent user experience. 8. Response to spikes. Auto-scaling can quickly respond to sudden spikes in traffic, such as during promotional events or sudden increases in user activity. 9. Integrated with other AWS services. Auto-scaling seamlessly integrates with other AWS services like Amazon CloudWatch for monitoring and Amazon Elastic Load Balancing for distributing traffic across instances. 10. Customization and automation. Auto-scaling can be customized with triggers, policies, and thresholds that match your application's unique requirements. 11. Global scaling. Auto-scaling can be applied to multiple regions and availability zones, allowing you to scale your applications globally to meet demand from different geographic locations. 49. What are security groups? Security groups acts as a firewall that contains the traffic for one or more instances. You can associate one or more security groups to your instances when you launch them. You can add rules to each security group that allow traffic to and from its associated instances. You can modify the rules of a security group at any time. The new rules are automatically and immediately applied to all the instances that are associated with the security group. 50. What are shared AMIs? Shared Amazon Machine Images, AMIs, are pre-configured virtual machine images used to create instances in Amazon Web Services, AWS. These images include the operating system, software, configurations, and any additional data needed to launch instances. Shared AMIs are images that you can create and share with other AWS accounts, or that other accounts can share with you. This sharing capability enables collaboration and simplifies the process of deploying standardized environments across different accounts or teams. 51. What is the difference between the classic load balancer and the application load balancer? The classic load balancer, CLB, and the application load balancer, ALB, are both load balancing services provided by Amazon Web Services, AWS, to distribute incoming network traffic across multiple instances or targets. However, they differ in their features, capabilities, and use cases. Here's a comparison of the two. Classic Load Balancer, CLB. 1. Layer 4 Load Balancing. CLB operates at the transport layer, Layer 4, of the OSI model and can distribute traffic based on IP addresses and port numbers. 2. SSL termination. CLB can terminate SSL connections from clients and then forward unencrypted traffic to the instances. SSL termination offloads the encryption-decryption process from the instances. 3. Sticky sessions. CLB supports sticky sessions, which enable clients to be consistently routed to the same backend instance to maintain the session state. 4. Health checks. CLB performs health checks on instances using the TCP protocol, checking whether instances are responsive on specific ports. 5. Cross-zone load balancing. CLB can distribute traffic evenly across multiple availability zones, helping to balance the load across the infrastructure. 6. Limited routing logic. CLB offers basic routing options based on the availability of instances, but it lacks the advanced routing capabilities found in the ALB. Whereas, Application Load Balancer, ALB. 1. Layer 7 Load Balancing. ALB operates at the application layer, Layer 7, of the OSI model and can route traffic based on advanced content-based routing rules. 2. Path-based routing. ALB can route traffic based on the URL path, allowing you to direct different requests to different groups of instances. 3. Host-based routing. ALB can route traffic based on the host header in the HTTP request, enabling you to handle multiple domains or subdomains with a single ALB. 4. Content-based routing. ALB supports routing decisions based on HTTP request headers, methods, and query strings. This is useful for directing traffic to specific instances based on specific criteria. 5. Dynamic port mapping. ALB supports dynamic port mapping, allowing multiple services on the same instances to be routed to different ports. 6. WebSockets and HTTP 2. ALB supports WebSockets and HTTP 2 protocols, making it suitable for real-time applications and modern web applications. 7. Security policies. ALB supports more advanced SSL, TLS configuration and allows you to define security policies for handling HTTPS connections. 8. Container-based services. ALB integrates well with container services like Amazon ECS and EKS, providing automatic service discovery and dynamic port mapping. 52. By default, how many IP address does AWS reserve in a subnet? By default, Amazon Web Services, AWS, reserves 5 IP addresses in a subnet from the available IP address range. These reserved IP addresses are used for various purposes within the subnet. The breakdown of these reserved addresses is as follows. 1. Network address. The first IP address of the subnet is reserved as the network address. This IP address represents the subnet itself and cannot be assigned to any instance or resource within the subnet. 2. AWS reserved IPs. AWS reserves 2 IP addresses within the subnet for internal purposes, such as routing, DNS, and other networking functions. These addresses are not available for assignment to instances. 3. VPC router. One IP address is reserved for the Virtual Private Cloud, VPC, router. This IP address is used to manage and route traffic within the VPC. 4. DNS hostname. One IP address is reserved for the DNS hostname. This IP address is used for DNS resolution within the VPC. 5. Broadcast address. The last IP address of the subnet is reserved as the broadcast address. While AWS doesn't actually use this address for broadcast, it's still reserved by default. 53. What is meant by subnet? A subnet, short for subnetwork, is a smaller and logically segmented network that is created within a larger network, such as a local area network, LAN, or a virtual private cloud, VPC, in a cloud computing environment. Subnetting is a technique used to divide a larger network into smaller, more manageable segments to enhance network efficiency, security, and organization. 54. How can you convert a public subnet to private subnet? Converting a public subnet to a private subnet typically involves adjusting the network and security configurations to restrict direct internet access for instances within that subnet. This is a common practice for enhancing security and controlling access to resources in a cloud environment. Here are the general steps to convert a public subnet to a private subnet in a cloud platform like Amazon Web Services, AWS. 1. Update route table. A public subnet has a route in its route table that directs traffic to an internet gateway for outbound access. To convert it to a private subnet, remove the route to the Internet gateway. 2. Attach network ACL or firewall rules. Make sure that the network access control lists, ACLs, or firewall rules applied to the subnet restrict inbound and outbound traffic according to your security requirements. This might involve allowing specific traffic from other subnets or security groups while denying direct internet access. 3. Modify security groups. Adjust the security groups applied to instances in the subnet to control their inbound and outbound traffic. For a private subnet, you might allow traffic from specific security groups or subnets while limiting internet-bound traffic. 4. Internet gateway removal. If applicable, if the subnet was originally associated with an internet gateway, detach the internet gateway from the subnet. This step is essential to prevent instances in the private subnet from having a direct path to the internet. 5. Update DNS configuration. If the instances in the private subnet require DNS resolution for internal resources, ensure that they are configured to use appropriate DNS servers within your network. 6. Validate connectivity. After making the necessary changes, validate that instances in the private subnet can still communicate with the resources they need, such as databases, other instances, and services in the VPC. 7. Testing and monitoring. Thoroughly test the functionality of the private subnet to ensure that it meets your requirements. Monitor network traffic, security events, and connectivity to identify any potential issues. 8. Documentation. Document the changes made to the subnet's configuration, including security groups, route tables, and network ACLs. This documentation will be helpful for troubleshooting and future reference. 55. Is it possible to reduce an EBS volume? Yes, it is possible to reduce the size of an Amazon Elastic Block Store (EBS) volume in Amazon Web Services (AWS), but with some limitations and considerations. Here's what you need to know. 1. EBS volume types. Not all EBS volume types support resizing. Only certain volume types, such as General Purpose, GP2, Throughput Optimized, SAINT1, and Cold HDD, SC1, allow you to decrease their size. 2. Data backup. Before resizing any EBS volume, it's crucial to back up your data to prevent data loss in case anything goes wrong during the resizing process. 3. File system resize. If you're reducing the size of a volume that contains a file system, e.g., an operating system or data volume, you must first resize the file system to a size smaller than the target EBS volume size. 4. Snapshot creation. Create a snapshot of the EBS volume you want to resize. This snapshot serves as a backup and can be used to create a new EBS volume of the desired size. 5. Volume detachment. Detach the EBS volume from the instance to which it is attached. You cannot resize an attached volume directly. 6. Volume snapshot restore. Create a new EBS volume from the snapshot you created earlier. During this process, you can specify the desired size for the new volume. This effectively restores the data to a new volume of the desired size. 7. Data validation. After restoring the data to the new volume, validate that the data has been restored correctly and that your applications function as expected. 8. Instance attachment. Attach the new resized EBS volume to the appropriate instance. Update any configurations within your instance to reflect the change in storage capacity. 9. Cleanup. After confirming that everything is working correctly with the resized EBS volume, you can delete the old volume and snapshot if they are no longer needed. It's important to note that while it's possible to reduce the size of certain EBS volumes, the process involves creating a new volume and restoring data from a snapshot. This process requires careful planning and execution to avoid data loss and ensure the smooth functioning of your applications. Always refer to the AWS documentation for the most up-to-date instructions and recommendations before performing any volume resizing operations. 56. What is the use of Elastic IP? Are they charged by AWS? These are IPv4 address which are used to connect the instance from internet. They are charged if the instances are not attached to it. 57. One of my S3's bucket is deleted but I need to restore. Is there any possible way? If you've accidentally deleted an Amazon S3 bucket and you need to restore it, there is a possibility to recover the bucket, but the success of recovery depends on a few factors. Here's what you can try. Contact AWS support. If you've deleted a bucket and need to restore it, it's recommended to contact AWS support as soon as possible. AWS might be able to assist you in recovering the bucket, especially if it's a recent deletion. Backup and restore. If you had a backup strategy in place, you might be able to restore the bucket from a backup. AWS provides tools and services like AWS Backup that can help you manage and restore backups of your S3 data. Versioning. If versioning was enabled on the bucket before it was deleted, you can recover the bucket by restoring it to a previous version. This is possible because versioning preserves all versions of an object, including versions of the entire bucket. S3 replication. If you had set up cross-region replication or same-region replication for the bucket, you might have a replica of the bucket in another region. You could use this replica to restore your data. Data recovery services. There are third-party data recovery services that specialize in recovering deleted data from cloud storage solutions. You might consider exploring these options if the data is crucial and cannot be recovered through other means. Prevent further changes. If you realize you need to recover the bucket, avoid making further changes to the S3 environment, as new changes could potentially overwrite or complicate the recovery process. Remember that the ability to recover a deleted S3 bucket depends on various factors, including the duration since deletion, whether versioning was enabled, and the specific configuration of your AWS account. It's important to act quickly and seek assistance from AWS support to increase your chances of successful recovery. 58. When I try to launch an EC2 instance, I am getting the service limit to exceed. How to fix the issue? Encountering a service limit exceeded error while trying to launch an Amazon EC2 instance indicates that you've reached your AWS account's limit for the specific resource you are trying to create. AWS imposes certain limits on the number of resources you can create within each service to prevent misuse and ensure fair resource allocation. To resolve this issue, you can follow these steps. Identify the limit. The first step is to determine which specific limit has been exceeded. The error message should provide information about the service and resource type that has reached its limit. Check current usage. Review your AWS account's current resource usage for the service in question. You can use the AWS Management Console, AWS Command Line Interface, CLI, or AWS SDKs to query your account's resource usage. Increase service limit. A. Request limit increase. If you anticipate needing more of the specific resource, you can request an increase in the service limit. This involves contacting AWS support and providing a valid reason for the increase. B. Using the AWS Management Console. Some services allow you to request a limit increase directly from the AWS Management Console when you encounter a limit exceeded error. Look for Request Limit Increase link in the error message. Provide justification. When requesting a limit increase, be prepared to provide a justification for the increase. Explain the use case and why you need more resources. The clearer and more detailed your justification, the higher the likelihood of a successful increase. Wait for approval. After submitting the request, AWS support will review it. The approval process might take some time, so be patient. AWS will evaluate the request based on your use case and other factors. Monitor resource usage. While waiting for the increase, monitor your resource usage and ensure you're not creating unnecessary resources that might contribute to reaching limits. Plan for scaling. In the future, consider architecting your applications to handle scaling gracefully. This might involve designing for horizontal scalability, using auto-scaling groups, and being mindful of service limits. Consider other AWS regions. If you're constrained by limits in a specific region, you might consider launching resources in a different region where limits are higher. It's important to note that not all service limits can be increased, and AWS considers various factors when reviewing requests. Be prepared to optimize your resource usage and demonstrate a genuine need for the increase. Always refer to the latest AWS documentation for specific guidance on requesting limit increases for the service you're using. 59. I need to modify the EBS volumes in Linux and Windows. Is it possible? Yes, it is possible to modify Amazon Elastic Block Store (EBS) volumes in both Linux and Windows environments. However, the steps and methods for modifying EBS volumes might differ between the two operating systems. Here's an overview of how you can modify EBS volumes in both Linux and Windows environments. Remember that resizing EBS volumes, whether in Linux or Windows, involves careful consideration and backup of data, as well as ensuring compatibility with the file systems and partition schemes in use. Additionally, EBS volume modifications might incur downtime for the instance, so it's recommended to perform these operations during maintenance windows or when the minimal impact is expected. 60. Is it possible to stop a RDS instance? How can I do that? Yes, it is possible to stop an Amazon RDS, Relational Database Service, instance. Stopping an RDS instance can be useful when you want to temporarily pause the instance to reduce costs, perform maintenance, or perform certain administrative tasks. Here's how you can stop an RDS instance. 1. AWS Management Console. Log into AWS Console. Log into your AWS Management Console. Navigate to RDS. Navigate to the Amazon RDS service page. Select Instance. From the list of RDS instances, select the instance you want to stop. Actions drop-down. Click the Actions drop-down button located above the list of instances. Stop. From the drop-down menu, select Stop to initiate the process of stopping the instance. Confirmation. A confirmation dialog will appear. Review the details and click Stop to proceed. 2. AWS Command Line Interface (CLI). You can also use the AWS CLI to stop an RDS instance. Open your command line interface and use the following command. AWS RDS stop DB instance, DB instance identifier yourinstanceidentifier. Replace yourinstanceidentifier with the actual identifier of your RDS instance. 3. AWS SDKs. If you're using an AWS SDK for programming, you can use the SDK to programmatically stop an RDS instance. 4. Impact of stopping. When you stop an RDS instance, its state changes to stopped, and you will not be charged for the compute resources during the period it's stopped. While the instance is stopped, you won't be able to access the database, and all ongoing connections will be terminated. The endpoint associated with the instance will also become unavailable while the instance is stopped. Automated backups and automated maintenance are paused while the instance is stopped. 5. Starting the instance. To resume using the RDS instance, you can start it again using similar steps through the AWS Management Console, CLI, or SDKs. Remember that stopping an RDS instance should be done with consideration for the impact on your applications and users. It's advisable to plan the instance stoppage during maintenance windows or periods of low activity to minimize disruptions. Always refer to the latest AWS documentation for detailed instructions and best practices for managing RDS instances. 61. What is meant by parameter groups in RDS? And what is the use of it? In Amazon RDS, Relational Database Service, a parameter group is a collection of database engine configuration values that can be applied to one or more RDS instances. These configuration values, known as parameters, control various aspects of the database engine's behavior, performance, and functionality. Parameter groups allow you to customize and fine-tune the behavior of your RDS instances according to your application's requirements.